Okay, so one or two, or any of those.
Any of them.
Okay. Let's cover this up. Okay, number 1 says to find the slope of the line passing through the given point. So you have 2, 0, you have negative 6, 8. Okay, and how do you find slope?
The rise over run.
It is rise over run. Okay, and rise, does that deal with x or y's? So the slope is rise over run. Okay, and your rise, okay, back up. Rise going up or down, right? So is that dealing with x's or y's? Mm-mm. Up and down is, what goes up and down? Which axis? The y-axis. So the slope is equal to y2 minus y1 over x2 minus x1. Okay? And this should be in your notes on that pink sheet.
Okay, I remember this now.
Okay, and so you can label your points if you want to. So let's see, we could do a different color. Red. So I could say this is x1, y1. Because remember, it's an x and a y and an x and a y. x2, y2. Okay, so what would I put first? What would I put in the top?
The 8 minus 0.
8 minus 0, good.
And then
Over,
negative 6 minus 2.
good. 8 minus 0 is 8. Negative 6 minus 2 is, so that would be negative 1 will be your slope. Does that make sense?
Yes, ma'am. I just didn't.
You just forgot.
Yeah, I just forgot what the direction was.
Okay. Lauren, do you have a question?
No, ma'am, I got it.
Okay, do you have a question about something else on the front of the sheet? Like another slope or perpendicular parallel stuff?
No, I got this.
Oh, okay, last time. Mariah, do you have any? Number 7, let's see. Let's go to 7. We write each equation in slope-intercept form. Okay, in slope-intercept form, then determine whether the lines are parallel, perpendicular, or neither. So it gives us 2 lines. This is number 7. Line 1, 2y is equal to x plus 1, and the other line is x is equal to 2y plus 5. So it says put it in slope-intercept form. So what does that mean? What is slope-intercept form?
Y equals mx plus b.
Right. Y equals mx plus b. Okay, so we want to get y by itself here, so what will we do first? This first equation. Is y by itself now? No, so what should we do? What's happening to it? By? Right. So you multiply by 2, so we divide by 2. So if you divide everything by 2, you're left with just y. And then what's in front of this x here? 1. So you have a 1/2 times x plus 1 over 2, 1/2. Okay, there's your first line. Is that in slope-intercept form? Is that y equals mx plus b? Good. Okay, and then what about here? Is y by itself? No, so what should we do first to get y by itself?
Subtract 2y.
You could. Do y'all want to do that? You could do subtract 2y and subtract x. I was thinking subtract 5 and then we could switch it. But what makes more sense to y'all? To move y over to the left side? Okay. We'll do that. So let's go ahead and move the y to the left side. So now I have x minus 2, let me draw a line here. X minus 2y is equal to 5. And now what do I need to do to get y by itself? Subtract x on both sides, okay? So I have negative 2y is equal to negative x plus 5. Why not put the x first? Right. And it doesn't have to be in that order, but a lot of times it's easier for y'all to recognize. It's x right there. Okay, so now is y by itself? We're close, almost, right? What's in front of y? So what's happening between negative 2 and y? What's happening here between them? They're being multiplied, so how do you get rid of that negative 2? Okay, divide by negative 2, divide everything by negative 2. So you're left with y is equal to negative divided by negative. So what's that going to, that's going to be a positive. Okay, and then what's in front of the 1? I mean the x? 1. So it's a positive 1/2 x. And then here it's plus 5 divided by negative 2. So this is an improper fraction. You can put it into a mixed number. That's normally easier to graph. So 2 goes into 5 how many times? 2. And then what's left over? 1/2. So negative 2.5. 5 divided by 2. You can do it, blah, blah, blah. If you divided $5 into 2 pieces, you get $2.50 a piece. So negative 2. So now the second part says, then determine whether the lines are parallel, perpendicular, or neither. So how do you, parallel lines, what do you know about parallel lines? Right, they never touch. What about their slopes? The same. The slopes are the same, okay? So where's the slope in this problem?
1/2.
Okay? So 1/2 is the slope. It's in front of x. And what's the slope over here?
1/2.
Are those the same slopes? Okay. So they have the same slope. So they are parallel lines. You don't worry about the y-intercept. You just say, okay, they have the same slope. They must be parallel lines. And what do you know about perpendicular lines? It's the negative reciprocal, right? They switch. It's reciprocal. The numerator and the denominator flip, and then if it's positive, the other one's negative. If it's negative, the other one's positive. Okay?
Is that the one that says that write the equation of the line perpendicular? Is that what it's talking about?
Which one?
5 and 6.
Let's see. Okay. Any questions about 7? Are we good with that one? Okay. 5 and 6 says write an equation of the line perpendicular to the given line that contains P. Yes, you have to go through, find the slope. Or actually, what number 5? What is the slope for this one?
2/1.
2/1. So if it's the perpendicular line, what would its slope be? If this is 2/1, the perpendicular slope would be negative 1/2. And then you finish writing the equation. Does that make sense? You flip it, that one's positive, that one will be negative. And we can come back to these if we need to later on. Okay, Lauren, what did you have a question about? Ma'am, the proof? Which one do you want to start with? Okay. Okay, 36. So it's given BC is congruent to DC. They already have that marked for you. And AC is congruent to EC. Prove that triangle ABC is congruent to triangle EBC. Okay, now forget the whole proof part. If you were to look at this triangle, would you say, yes, I can prove them congruent?
Yes.
By what?
Side and side.
Okay, and where are the angles?
The
the vertical angles. And you would say side angle, side. So all you do in your proof is you're stating everything. You're stating the side, the angle, and the side. Okay, so what do you want to put for your first statement? Okay, we could say BC is congruent to DC, and that's given. Okay, do you want to put both of these on the same line? Both of the givens? Okay, let's say AC is congruent to EC, and that's already marked in the picture. So those are your two sides. You've got BC is congruent to DC, and AE is congruent to EC, just like that. Okay, so what's not, so we have the two sides. What do you need to list now?
The angle.
The angle. Okay, so name those angles. Well, they both use that point C, so you have to be very specific and use 3 letters. So what would you write? Angle BCA is congruent to angle, yeah, if you want to put DC, those are all corresponding parts. BCA and DCE, and what's the reason for that? Good, the vertical angles theorem, or you could say vertical angles are congruent. Either one. Now, we've mentioned the two sides and the angle. Is that enough to prove the triangles are congruent? Yes. So what would step 3 be? Because we've mentioned, let's see, we've mentioned a side, an angle, side, an angle, another side.
Now wouldn't you like do the proof instead of the
Well, now we'd say triangle ABC is congruent to triangle EDC because we have enough information. And so what's the reason for that? Yep. Okay, so the given information, angle 1 is congruent to angle 2. We have that marked already. AB is perpendicular to BL. So what would be the reason for that? That's given. Okay, and then we know that KL is perpendicular to BL. So down here, what's the reason for that? Given. So that means the angle B is a right angle. And how do we know that? That would be the definition of perpendicular lines. Or, let's see. Because we know these are perpendicular to each other, therefore we know it's B is a right angle. So that would be one answer choice. B is a... Okay, and angle L is a right angle. What would that be? Okay, angle 1 is congruent to angle 2. Why is that? That's given. Okay, and notice for the, I guess the 6th period didn't see a flow proof. Then B is a right angle and angle L is a right angle. It comes together to say angle B is congruent to angle L. And that's one of your theorems that says all right angles are what? Congruent. And that's probably on their pink sheet. That was probably one of the last ones. All right angles are congruent. That's how you could say angle B is congruent to angle L. Okay? How do we know that AB is congruent to KL? That's also given. AB is congruent to KL. No, it's all right angles are congruent. That's what it is. That's what you write down. You don't have anything special. But, okay, and then how do you know these two triangles are congruent? Okay, do you see 2 pairs of sides marked? Right, you have the two angles and the one side. Is the side in between those two angles? No. So it'd be angle, angle, side. Does that make sense? Segment QS is parallel to segment RT. Okay, and we know the angle R is congruent to angle S. So the first reason is given, so we can write that down at least first. Okay, and we're trying to prove that angle QTS is congruent to angle TQR. Do you agree that those are the corresponding angles within those two triangles? They kind of match up, right? So if I can prove these two triangles are congruent, is that going to prove their corresponding parts are congruent? It will. Okay. So if these two lines are parallel, what does that tell you? Alternate to your angle. So if you look at the parallel lines, this line is parallel to this line. Try that again. Right? Now this is, and this will be your transversal, it touches both lines. So do you see that this angle is congruent to this angle? Be careful, you have to use three letters because Q has 1, 2, 3 angles attached to it. So Q has to be in the middle. You name the angle. You can say SQT, angle SQT is congruent to angle T has to be in the middle, right? RTQ. Q and T are your vertices for those two angles. Say SQT and RTQ. But look, S has no other angles attached to it. I could say angle S. But here, angle Q talks about this angle, it talks about this angle, and it talks about the whole angle. So you have to tell me exactly which part you're talking about. Okay? So alternate interior angles are congruent because the lines are parallel. So they have, this angle is already given. We have that angle now. Do you notice anything else about the two triangles? They both share QT, right? So, is that reflexive property? Good. Okay. Triangle SQT is congruent to triangle. So you have to make sure they're in the correct order. What corresponds to S in the other triangle? R. What corresponds to Q? T. And what corresponds to T? Q. By angle, angle, side. You see that? Angle, angle, side. Angle, angle, side. And since these two triangles are congruent, we can now say the angle QTS is congruent to angle TQR by CPCTC. Does that kind of make sense? Okay. Okay, number 33. What do you notice about 33? how do you know it's equilateral? You see how all three sides are marked congruent? So that means that all three sides are congruent, which also means it's equilateral and equiangular. Equilateral and equiangular, which means all three angles are congruent. Okay? So that means that all three angles are congruent. This is congruent to this, is congruent to this. And all three angles should equal 60. If you take 180, divide by 3, each angle is equal to 60. So that means y minus 10 is equal to 60 from this angle up here. So how would I solve for y? Good. So add 10 to both sides. So y is equal to 70. Good. And then x plus 5, what would you set that equal to? 60, because it's also an angle in the equilateral triangle. Subtract 5. Good. So x is 55. Just this one. These are going to be isosceles here. Just have to use information given. Okay. Amanda, what's your next question? Okay. 5 and 6. Okay, number 5 says, write an equation of the lines perpendicular to the given line that contains P. Okay, so your line is y equals 2x minus 3. Okay, and the point P is negative 6, 5. Okay, and if you look in your notes, we have, this is slope-intercept form, right? And what about point-slope form? If you have the slope and you have the point, does that look familiar? X minus h plus k? I gave you the notes, and then this table helped you with it when I was gone. Okay. Okay, and we're talking, so this is your point-slope form here. And we're talking about, no.
Just write that equation.
And you're filling it, well, be careful. Okay, first of all, what's the slope for this line here? The slope is 2 or 2 over 1, okay? So for the perpendicular slope, what's it going to be? It's 2 over 1, so you're going to write the reciprocal, 1 over 2, and this is positive, so this will be negative. So that's your perpendicular slope. Okay? So now I have, what goes here? Here, let me add this. Okay? M stands for what? Slope. Oh, cool. Okay. I'm learning new things. Okay, that is your slope. Okay? And then H and K would be your point. Your H and your K are your point. Okay, so over here, let's plug in our slope. What would our slope be? The new one, because you're writing the line that's perpendicular to it. Negative 1/2 times x minus, what's our H? Negative 6. So it's going to be positive, minus negative 6 makes it a positive 6, plus, what's the K? 5. Okay, and then what do you do to simplify it? Yeah, you could keep it like this if you wanted to. If you want it in slope-intercept form, you distribute 1/2 times x. Then what's negative 1/2 times 6? Negative 3, and then plus 5. So what's negative 3 plus 5? Positive 2.
But if I put this on the test, I was left it like that, would that be?
You could.
Okay.
You can. Okay. Does that help a little bit? Okay. Let's see. Lauren, what's your next question? Complete each statement. Explain why it is true. Okay, so 27. Angle DBC is congruent to what? Which is congruent to CDB. So if you look at this triangle, I know this picture is kind of small, you can see that this is congruent to this and it's congruent to that. So all three sides are congruent, which means it's what kind of triangle? All three sides. It's equilateral, which also means it's equiangular. That's one of the corollaries we have in your notes. If it's equiangular, it's going to be equilateral. If it's equilateral, it's going to be equiangular for the triangles. So angle DBC is here, DBC. Angle CDB is here, CDB. So what's the other angle it's congruent to? Angle C. You could just put angle C here because there's only one angle that goes with it. Or you could say angle BCD. And there are other answer choices for this, but that's the most obvious one. And if you explain why this is true, you would say it's equilateral and equiangular. That's one of those corollaries. Okay, do we need to keep going with these? Okay, 28. Angle BED is congruent to what other angle? It's actually BED and BDF, and I'll draw the picture so you can see it. Or sorry, BDE, not F. Sorry, BDE. Let me erase this. D has to be in the middle. If you said EDB, that'd be okay. Okay, look. Here's this triangle. You see how these two sides are marked congruent? We're talking about this triangle in here. Everything is green. So it said angle BED is congruent to angle BDE because it's an isosceles triangle. And those are the two base angles. So you could have said EDB or BDE. Those are the only two choices. Does that make sense?
But, so, it's like that because, like, they're all equal to each other?
What do you mean?
Like, the sides.
Okay, I'll redraw the picture.
Yeah, I was asking if you don't like
Okay, here's the triangle. BE has one marking, and BD has one marking. So therefore, that's congruent to that. Does that help? A little bit? Okay.
But isn't there like lines on the bottom?
Yeah, they're double lines. That deals with this. That smaller triangle in here. Okay, speaking of that one, that is the next one. Angle FED here is congruent to what? Which is congruent to DFE. So once again, all three of these sides are congruent. So it's an equilateral and equiangular triangle. So what's missing? Angle D has to be in the middle, right? It's the vertex. So FDE. What did you say? EDF? That's right, too. Okay, and the last one, AB is congruent to what? Which is congruent to BE. And this, you really could have other answers, too. But what did you put? What did you say? EA or AE? Good. And that should say segment. Because it's equiangular, so that means that it's equilateral. Okay, 13. Okay, it says y equals 1/4 x. Okay, it says graph each line mentioned below and the perpendicular line through -2, 1. Okay, so y equals 1/4 x. You graph that first. See ya. See you tomorrow. Do we have a y-intercept? No. We had +0 out here, right? There's nothing there. So we go up 1 over 4. Up 1 over 1, 2, 3, 4. And we don't have any room to go over anymore. So you could go down 1 over 1, 2, 3, 4. To go backwards.
So let me go down from that point.
You would see this, the slope is, look, if you go, start here, go up 1 over 1, 2, 3, 4, up 1 over 1, 2, 3, 4. Rise over 1. So I had to go backwards. Down 1 to left 4. Okay, so now me drawing a line on this is not going to work out too well, but let's get my line tool. Okay, and then I will try. Okay, it should go out further, but that's the best I can do on the computer. Okay, and it should go through. Oops, no. Back to this. No. I don't want the line. Okay, and then it says a line perpendicular through -2, 1. Okay, so the perpendicular slope would be what? It would be -4. 1 over 4, the reciprocal is 4 over 1, and that's positive, so this will be negative, because that's the slope here. 1/4. So you flip it, and that's positive, so this becomes negative. The slope is -4, 1, and it goes through point -1, 2, 1, right here, right? It goes through that point. So once you graph that point, then you just use the slope. You say, okay, -4, 1, 2, 3, 4 over 1. -1, 2, 3, oh, almost. Or go. Hold on. Okay. It said go through -2, 1. So I did -2, 1, and I'm going through there. So let's try my line tool again.
So the -2, 1, is that like the y-intercept, basically?
Kind of. I mean, it's just a point that it goes through. So you can just graph that point, and you know it's going to go through the point, and then choose the slope.
But always, like, you always, like,
parallel to AB that contains point C. Okay, so very similar to these graphing problems, it's just you're not graphing them. Okay, so your line is y equals -5x plus 12, and your point is -2, 1. So write an equation of a line parallel that contains point C. So once again, this is like, I think we did number 5. This is going to be the same thing, except it's a parallel slope. So what's the slope for this line? -5. So what's the parallel slope going to be? It's going to be exactly the same. It's going to be -5 because they're parallel. Okay? So now, what's that point slope formula again? Point slope form? Good. So we can use that. We'll see. Okay, so now we have our slope and we have our point that we're going to use here. Okay? So you just say y is equal to, what goes here? -5. X minus, it's going to be +2, right? Because it's x minus -2, so it's a +2. plus 1. Okay, and then we could get in slope-intercept form. You just distribute like this. What's negative 5 times x? What's negative 5 times 2? Then plus 1. So what is your negative 5x minus 9?